This is the Tree of Life, Season 14, Chapter 9. In this episode, we will be talking about Shannon information entropy, or configurational entropy in the context of the binary logarithm. To start out, in the last episode, we talked about how for a 5-person structure, comprising persons A, situated above persons B, C, D, and E, where person A affirms an impulse and negates the dialectical impulse for persons B, C, D, and E, there are 16 distinct conformations associated with that structure. Now, we also talked about how the duration of the periods associated with the flipping of phase for any one structure member impacts the overall number of conformations available to the structure. In this episode, I would like to talk about how the highest entropy associated with the structure is present when there is a binary logarithmic relationship between the periods associated with each microstate. If you start out with the idea that the number of conformations available to the structure is the number of structure members, minus 1 to the exponent 2 for 2 states associated with 2 dialectical impulses, then, a 5-person structure, comprising 4 individuals around some person A, possesses a total number of conformations of 16. If you imagine that person B flips phase from affirmation of impulse 1 and negation of impulse 2 to affirmation of impulse 2 and negation of impulse 1 every 16 seconds. And you imagine that person C flips every 8 seconds and person D every 4 seconds and person E every 2 seconds. Then you will see that in a 32-second overall time frame, all 16 conformations occur. This relationship between the period of each structure member is defined by the binary logarithm. Thus, we see that the greatest conformational entropy is provided when there is a relationship between the periods, which is defined by the binary logarithm. Now, what this also means is that if you depart from either 2 times the period of the longest period associated with flipping of phase to determine the entropy, or you depart from a binary logarithmic relationship between the periods associated with each structure member, you end up with significantly less conformational entropy due to fewer available microstates. Thus, we see that the stacking described in the last episode with respect to the periods associated with given structure members, which is described by the binary logarithm, essentially describes the highest entropy state associated with a particular bodily rhythm or cycle. Thus, we see that there is a tendency for the orders of the bodily rhythms or cycles to fall into the binary logarithm. This tendency maximizes the entropy associated with a given structure. Thus, we can observe that when sublimating language is used at the conclusion of a substitution event to elongate the phase with respect to a particular cycle or rhythm, we can see that the resulting new period for the rhythm will tend to fall into the binary logarithm as well. That's the end of the podcast for today.